Okay. I've been asked to do some examples of simplifying some more difficult exponent expressions. So here I'm going to go over just how to simplify some things involving expressions that involve both like the product and the power rules, the quotient and the power rules, and some things with the negative exponents. Now, I'm not going to review those rules specifically, but I'm going to show you just basically some strategies and some thoughts of how you should go about simplifying these. So, first one I have here is something like this. So here is our first example. I've got 4y cubed z times x cubed y z squared to the fourth power. So with this, whenever you see something like this, when you see two different expressions, you need to do that power rule first. So here I'm going to apply that power rule. So x cubed to the fourth, that will be x to the 3 times 4 would be 12. Y to the fourth would be y to the fourth. Z squared to the fourth would be z to the eighth. And now I get my 4y cubed z. Now at this point, we're just down to our product rule. So I don't have any other coefficients to multiply, so I'll just leave that 4 there. I like to put things in alphabetical order. So I don't have any x's in this first one, but I do have one here. So that'll be x to the 12th. Y cubed times y to the fourth would be y to the 7th. And then z times z to the 8th will be z to the 9th. Again, if you don't have remember, if you don't have an explicit exponent on something, we assume it's a 1. Okay, let's move on to our second example. I've got negative 2 a to the 7th b to the 4th times negative a squared b cubed. Now here I'm involving some negative numbers. My trick with this is to figure out your signs first, and with that, I will just basically add up the number of negatives I will have. This will give me 3 because I'll have negative times negative times negative. Then I've got one more negative. I've got an even number, and every pair of negatives cancels each other out. So I know that ultimately, I know this is going to resolve to be a positive. Although this expression right here will end up being negative because I'll have negative times negative times negative. All right, after that, it's just a matter of applying those power rules. So here I've got negative, I will have negative times negative times negative, which will be a negative. And if you prefer to have a negative 1 there, you're welcome to. A squared cubed will be a to the 6th. B cubed will be b cubed. Now I'll have negative 2 a to the 7th, b to the 4th. I'll multiply my two coefficients here. That would be just positive 2. A to the 7th times a to the 6th will be a to the 13th. B to the 4th times b cubed will be b to the 7th. That was example 2. I'm going to throw you just a minor curveball on this last one with example number 3. And let's say we've got a squared, b to the fourth, c to the fifth, and I'll multiply that by, I'm going to do like 5 squared, a b to the fifth, c to the fourth, all of that to the 0 power. Now, the thing here is I will usually tell people to simplify inside that set of parentheses. Now, I'd only have one thing to simplify there, but that 0 power basically tells us that this entire expression will turn into 1. So this whole thing is just going to be equal to 1. Which means I'm only left with this times 1. I'll just be left with a squared, b to the fourth, c to the fifth, and we'd be done right here. Okay, I'm going to switch now to some of our quotient and power rules. So with this, let's say we've got something, and I'll start fairly simply, and I'll do something like, I'll do 4m cubed n. This might seem to be a little bit out of focus here. I'm going to do this times negative m over n squared cubed. Now, again, if I could simplify inside here, I would, but I have to apply my power rules first. Negative times negative times negative means I'll have a pair that cancels out and one negative left over. So this is just going to be left with a negative. And now I just apply that power rule here. That'll be m cubed over n to the sixth. And this is times our 4m cubed n. Now, if you've got just a single expression out here, if it doesn't quite click with your brain, you can always put this over 1. And now when we apply our quotient rules, then you can simplify things like this. Well, our m cubed times m cubed, I only have one constant here in this whole thing. So I'm left with that 4. I'll have my m cubed times m cubed, which will be m to the sixth. And then I have my n over n to the sixth, which will leave me with an n to the fifth because I subtract my exponents. And that negative just follows along. So this one's tricky in a couple ways because I'm multiplying something afterwards. I'm doing a product and I'm doing both a product and a quotient rule and a power rule. So I'm going to actually do that again in our second example. Okay. For our second one here, I'm going to do negative 6xy times negative 16 y to the sixth over 24 xy to the 10th cubed. Now again, let's look at our signs. I'll have 1, 2, 3, 4. So I know that ultimately my answer will be positive. It's good to kind of establish that right away. And don't let larger numbers intimidate you. Confidence is also a problem-solving skill along with patience. So I need to simplify inside this set of parentheses before I do anything else. So I see 16 over 24. I see these are both multiples of 8. So I'm going to simplify those. That'll be 2 over 3. 8 goes in 16 2 times, 8 goes in 24 3 times. I don't have anything to simplify that x with, but again, I follow my larger power, 10 minus 6. So y to the 6th over y to the 10th would leave me with n minus 6 would be 4. So now that we've simplified inside here, and if you're having a hard time sort of visualizing what we have left in there, that's negative 2 over 3xy to the fourth, and then I'm taking that cubed. So that'll be, this will be negative times negative times negative, would be negative. 2 cubed is 8. 3 cubed is 27. Then I'll have x cubed y to the 12th. And I still have, I'm going to bring this negative 6xy over. Now, negative times negative is positive. I'm going to simplify what I have left. I can't simplify these, but I could simplify this. And again, if it helps, I'll just put this over 1. You don't have to do this. Just remember whatever is left out here without anything in the denominator has a denominator of 1. Now 6 doesn't go to 27, but 3 does. So 3 goes into 6 2 times. 3 goes into 27 9 times. For my x's, one of these x's is going to cancel out, so I'll be left with an x squared down here. Actually, it's a little hard to see that, so I'll put that as x squared. And one of my y's will also cancel out. So I'll end up with y to the 11th. So now I multiply, I'll just multiply straight across, and I'm only left with 2 times 8, so 16 up top. Down below, I've got 9 x squared and y to the 11th. Okay, let's do another one. Now, sometimes you're going to have to apply, simplify what's inside your parentheses first. Other times you can't simplify what's inside the parentheses. You just have to deal with whatever your power are, whatever your powers are. So let's do, this will be example 3 of our quotient rules and power rules. And say I've got 4u cubed squared. And that's going to be over 2u cubed. Now, this isn't one big set of parentheses, so I can't simplify these. I have to apply my power rules first. Well, that's fairly straightforward. 4 squared will be 16. U cubed squared would be u to the 6th. Down below, 2 cubed is 8, and u cubed is just u cubed. So now that we've applied our power rules, now I can just apply my quotient rules. And, well, gosh, 8 goes into 16 2 times. And with my quotient rules, again, we follow our larger exponent. 6 minus 3 would be 3, so there's my power on my u. I don't have anything left here in my denominator. That's basically 1 times 1. So I'm going to have 2 times u cubed, or 2u cubed over 1, or just 2u cubed. All right. I'm going to keep going here. For my 4th example involving our quotient rules and power rules, I'm going to do another kind of this type. Let's say we've got x to the 4th y to the 5th. I'll put that over 3x squared y cubed squared. Again, two separate sets of parentheses. If I could simplify inside these individual sets of parentheses, I would. I can't. So let's go ahead and just apply our power rules. Y to the fourth to the fifth, or sorry, x to the fourth to the fifth would be x to the 20th. I'll have my y to the fifth. Don't let the larger exponents fool you. It's okay to have, they're just numbers. They're not going to hurt you. 3 squared would be 9. X squared squared would be x to the fourth. Then y cubed squared would be y to the sixth. All right. I only have my one coefficient, and it's down here in my denominator. So I'll have my y, or my 9 down here. Following our larger exponents, 20 minus 4 would be 16. So I'll have 16 for our exponent on the x up top. And then for our y's, I've got my larger exponent on the bottom. 6 minus 5 would be just a 1. So I'll just end up with a single y down below. Okay. Let's talk about some examples involving our negative exponents. And with negative exponents, I'll usually tell folks to resolve the negatives first and then simplify, but if you can, resolve those negative powers first. So here's our first example of our negative exponents. And I'm going to do c to the fourth over d squared, all to the negative 2. Well, I can't simplify inside this set of parentheses, and I'm going to deal with that negative exponent before I do anything else. So I'm going to apply that negative, which means this takes the reciprocal. That'll be d squared over c to the fourth squared. Now I'm going to apply that power rule. D squared squared would be d to the fourth. C to the fourth squared would be c to the eighth. Okay, I'm going to do another negative exponent example here. So this is our second one. And here I'm going to make this a little bit trickier. I'm going to do x to the negative fourth over y squared z to the negative third. All of this to the negative third power. So I say resolve these negative exponents first, if you could. Now I only have one x, one y, and one z. So all this really involves right now is moving these terms around. So I have an x to the negative up top. That's going to move. That one's going to move down. I got a z with a negative on the bottom. That'll move up. So that'll leave me with z cubed up top. That y squared doesn't move. It only had a positive exponent on it. Then I've got my x to the positive fourth now, all to the negative third. Now I'm going to deal with the power rule, and I'll deal with the negative on that before we do anything else. So I'll resolve that negative first. That'll be y squared x to the fourth over z cubed. So the negative exponent basically takes the reciprocal of a term. Now let's deal with our power rule. Y squared cubed will be y to the sixth. X to the fourth cubed will be x to the 12th. Z cubed will be z to the 9th. for our last example here, this is example 3 of our negatives, we're going to do something that involves both of these things. So I'm going to do r cubed s to the -2 over r to the -5 s to the 8th. I'll do this whole thing to the -5th power. So with this, first I'm going to simplify what's inside here. So I'm going to move my negative exponents. The negative exponent down here will move up. So what that means is I'm going to end up with r cubed times r to the 5th up top, or that would just turn into a single r to the 8th. I'll move, I've got this s squared, x to the -2, and that's going to move down. So that means I'll have that original s to the 8th here times an s squared. So that's going to leave me with s to the 10th. All of that to the -5th power. Now I'm going to apply my negative power rule, flip this. So that'll be s to the 10th over r to the 8th. All of that to the +5th power now. And now I'm going to apply that power rule. That'll be s to the 50th over r to the 40th. That's some big powers there. All right, hopefully this was of use to you guys, and I will see you in the next video.